All right, YouTube. Hello. Thank you for watching. Today I'm taking a look at another pair of speakers from the mid 70s, like most of my speakers are. And these are made by H.H Scott, and these are Pro 100 speakers. They would have been made probably around 76, 77, somewhere in there. They're a very unusual speaker. Anytime I see something this unusual, I pretty much gotta have it. Now down here in this door is all kinds of goodies, a bunch of switches. I love seeing switches because that just means that there's many things that they do that I can change to make them do something else. Now the weird thing about these is the speakers on top, kind of a duplicate mirror image. Now I would expect this switch right here, it says top speakers, it's a 3 position. I kind of expected that to switch these off at some point completely. It does not. And this one's labeled tweeter, this one's mid-range. So it's basically just an attenuator switch that knocks some resistors in line with the speakers. One of the things that makes this box just super unusual is this here. You notice there's no speaker wires on the back. There's no panel, no jack for speaker wires. They are all underneath, which isn't really the friendliest thing in the world. So right there you can see where they cut the hole in for it. And it's just a piece of hardboard that's laying in there that has some power resistors on, some caps, and some inductors. If you look here, it says controlled impedance. Impedance is 4 ohms. That's pretty low, for my standards anyway. They're telling you if you're running a lot of power, put a 2.5 or a 3 amp in it. If you're running 60 watts or less, put a 2 amp fuse in the AGC holder there. But the impedance to the speaker cabinet is what I want to focus on a little bit. Now I could put an impedance meter on it and run it across the frequency range and see what it looks like, but there's really no need for me to do that because I know what it's going to look like just by looking at how many speakers are in this cabinet. I use a lot of Sansui amps, integrated amps, and they're not going to pull anything more than maybe an 8 ohm load. Trying to run a 4 ohm load on those, there's a really good chance you're going to toast a lot of the Sansui amps. For a 4 ohm load, you really need something that's got a lot of transistors on the output stage paralleled up, something that has a lower voltage power supply than the Sansuis, and at higher currents, where the Sansui amps would be a higher voltage at a lower current. So right there we are, we got 5 speakers setting in this, and that's going to be an impedance issue for me. But I think these cabinets got some potential to them. What do you think, Crickies? Yeah, Crickies kind of likes it too. He resides in the cabinet there and he supervises me. So I don't know if anybody else that's into speakers, you would probably agree with me on this. The worst thing is when you get a pair of speakers that you find out that the woofer isn't the original woofer to it. Way too much that's been happening to me lately. But on a good note, I got these for a good price. Yeah, oftentimes you pull a woofer out and you say, oh man. So you see what I mean. A pair of Goldwoods with a 20 ounce magnet on them. Yeah, that's just not going to work for me. And you also see that this is a 4 ohm Goldwood as well. and it looks brand spanking new. So I would venture to say that somebody just put this woofer in there. My thoughts on this speaker: get rid of this gold wood, put an 8 ohm 15-inch in here, and then at that point I can go through and check these speakers, see what the impedance of them looks like, and kind of go from there. But I think what's ultimately going to happen here is I'm going to have to pull 2 speakers out of this whole entourage to get the impedance where I want it to be for my amps. And since this switch here does not, in fact, turn off the top 2, I think I'm going to have to make it turn off the top 2. Basically make a 3-way with the tweeter, the mid, and the woofer, and then switch the top 2 in some means with a resistor in, or by changing the crossovers or something on them, in a way that doesn't have a significant drop in the impedance of the speaker. So that's kind of my goal for these speakers, is to put new woofers in them. And unfortunately, I will have to add or build new crossovers for them, or more to the point, add parts to the crossover to make them do what I want. I think it would be kind of cool to do it that way in the switching of these, because essentially what you could do, instead of bringing both of these on, or all 4 of these on, is you could split them up just to see what happens. One position on this switch sets a 3-way here with them, and then when you flip the switch the other way, it kills these 2 and puts these 2 facing upwards. I don't know what that would do. I've never had a bass speaker forward and the mid and the tweeter facing upwards. Now, the reason I say I think this has potential is because of the cabinet. The cabinet's made well enough that I think it will make up for the money that it would cost to make this speaker sound like $1,000. I kind of questioned the polarity on that woofer, but they did in this one actually use black for the positive and white with the black tracer for the negative. So there's a what looks to be 6.7 microfarad on that one, 20 mics on that one. Looks like there's a 4 ohm 10 watt there, a couple of 2 ohm 5 watters. It looks to be, they might be wired in parallel. This undoubtedly is the inductor for the woofer. I don't know if one of these caps here coincide with that. So I don't know if the woofer is on a 12 dB per octave roll off or just on a 6 dB with the inductor in series with it. There's a pretty good mess, and things are not really so easy to just look at. I don't know if they sealed around this bottom plate or not to make the enclosure airtight. 6 to 1, half a dozen to the other on that. You see they got her stacked in there pretty good on the fiberglass. They actually have a brace up here too. From front to back, that's another 1x2. And that's poplar. You can tell it's poplar by that yellowish green color that sometimes gets like darker streaks in it there. So I think this speaker cabinet is the bonus to the fact that I took a bit ahead on the woofers. And this is absolutely the most important thing that I can't stress more than anything in my whole entire life. When you put acoustic stuff in a cabinet, you don't spray the whole crossover down with 3M, because this stuff's flammable as all get out. The last thing you want is a major inferno in your speaker cabinet that you really can't extinguish. Now, if you can find this stuff in these super tiny cans here, which is some work, this is a ticket. because you can fit these in the whole box and you're less likely to spray stuff that you don't want to spray. For the love of God, do not spray the wires, because if this stuff comes in contact with that, you're going to be so wrapped up, and this stuff is super strong. If you pull on it, those wires are going to break long before these strands break away. Don't spray too close to where the crossover board is. And then take a piece of fiberglass and cut it out and stack a piece of fiberglass on top of this, and then continue to fill your acoustic stuff on top of it. That way there's a fire barrier. Do not, under any circumstance, allow this stuff here to come remotely close to where your screw holes are. Strands of this meets that screw. When that screw's spinning through there, it'll grab those two strands and suck them into your T-nuts, and it'll draw half of your cabinet of this stuff up into a big knot, and you'll be stuck. There'll be nothing you can do to get the speaker out, because this will never back out of the T-nut. You see what I'm saying? You won't be able to get your bolt out. And what you'll have to do is, hopefully there's not more than one of them that did that, you'll have to take a grinder, and with your woofer installed and your screw likely in a position where the head of it is probably not any further out than what that is right there, you will have to find a way to cut the head of that bolt off just to get your speaker out of the cabinet. These are crazy handy to have, because you take a big glob of this and you just keep adding it into a grocery bag, and you can weigh it out. So that's like 40 grams right there. That way you don't end up with one speaker cabinet that's got too much dampening in it. You can buy these things from Esco. I don't think they were much more, maybe $10 or $15. You can get these in all different sizes. This one here goes up to 500 grams. I know they have ones that are smaller than this and ones that are larger than this. These are crazy handy to have. You could probably weigh your pet fish on these as well. Actually, I didn't notice this till now, and that does make sense, because I was wondering, where's all the power resistors for those attenuator switches? They're all down here. A whole bunch of them in there. So you don't want to put any glued polyester down in there. And once I get all this in here, then I can go around and get this away from the holes more by putting some fiberglass in there. It looks to me like this one will go in. It's just going to be a little touchy. Well, that probably wasn't the thing to do there. Not glued very well. See what I'm saying? That's all it really took to get that off of there. This thing's a 75-ounce magnet, so it's pretty tough pulling those things in and out. But honestly, I didn't expect the gasket to come off on that. This one here is also a gold wood, which I wish it wasn't a gold wood, but anyway, I didn't have a lot to work with. As far as a 15-inch speaker goes, there wasn't much to choose from, but this one here is an 8-ohm, and this thing is an absolute beast. I think there's kind of an upside and a downside to that. I can't find any data on this speaker, so I need to find out what the crossover values are for the woofer. Let's just kind of see what we got in there. 3 inductors. Yeah, it's got to be that one. L1.0, I don't really know what that means. Their wiring's kind of bass-backwards. The black wire coming off the end of the fuse holder, the only thing it's going to is the positive for the woofer. So, yes, this inductor is, in fact, the low pass for the woofer, and it is isolated when the woofer is out. Now, is it a 6 dB per octave or a 12 dB per octave? Kind of remains to be seen, because the way they wired this just doesn't make immediate sense to me. Well, if this black wire is going to the positive of the woofer, and if I can clearly see that there is no capacitor coming off of that fuse holder, here where the black wire is at, or really even for that matter on the other side where the inductor is soldered to, that tells me that there is no cap for that woofer, which means that it's 6 dB per octave. There is no capacitor shunted to ground. As far as judging by the values of the caps, even if I didn't know what I already know, a 6.7 is actually would be too low a value for a low pass, and that 20 would be questionably low in value to be in a low pass filter as well. So I think it's safe to just basically see if we can even read across that inductor with this meter. 1061 microhenries. So that would be 1 millihenry. That's not going to be enough inductance on this woofer. And I was kind of afraid of that. Sometimes when you go to redo something, you get lucky because you find out there's a bigger inductor than what you actually need, and you can just take the inductor out and pull turns off of it. I've even added some turns onto inductors already if it's not a lot. The old trusty Parts Express books, the only company I know that's actually left and actually still puts out catalogs, amazing as that is Crossover Component Selection Guide. This is kind of like my Bible over the years, so to speak, because anytime you want to know a crossover value, they got all the charts right here. And this will kind of tell us, too, whether or not this woofer that was in here was a 4 or was an 8. I need a crossover frequency about 500 hertz on the low pass. Everything below 500 comes through on the woofer, and everything above 500 comes through on this guy. This guy here will definitely take 500, although I don't know that I'd want to go down any lower. This just ain't working out. For 500 hertz on a 4 ohm woofer, I'd need 1.27 millihenries. For 500 hertz on an 8 ohm woofer, I'd need 2.55 millihenries. So unfortunately, that choke's going to have another choke put in line with it, in series with it, to give me 2.55. So it's kind of messed up, but you know, it's important because copper is very expensive and inductors are very expensive. You don't want to have to be replacing or buying new inductors unless you absolutely have to. So this choke, I'm going to have to cut and put another choke in series with it. And I can actually change that to a 12 dB per octave, which will change the value that I need to add to it. But I'll have to shunt a capacitor to ground to do that. I guess for now, I'll just go ahead and install this woofer. And then at a later time, I'll come back and add the components back in to make this woofer run in the frequency range that it should be in. having one in there that's too small is not going to affect anything in the meantime, other than it's just going to send much higher frequencies through this woofer than what I really want. The bass is all still going to come through it just the same as really anything. At 6 dB per octave, 1 millihenry on an 8 ohm woofer would be a low pass at around 1.1 K. That's very, very high. I'm going to get these new woofers in and give it a go here. Thanks for watching. You take care and have a great day.